Triangle inequality theorem. A triangle has two sides that add up to more than the third side. Notice the illustration with the length A, B, and C. We could say here that the sum of two sides is greater than C. In other words, you cannot always make a triangle by attaching the segments at their endpoints, given three lines, since the third side should be greater than the two sides. Proof of triangle inequality theorem. Given triangle MNO, with angles 1, 2, and 3, prove MN, the distance MN, plus the distance NO is greater than the distance MO. You have your statements and reasons. 1. Extend line segment ON to point Z so that NM equals NZ. So take a look in the illustration and notice the ON, line segment ON, or the distance ON extending to Z, the point Z. Actually, we can form a new distance or a new line segment NZ. That's why it's equal NM equals NZ. The line segment NM is already existence niya. We've been doing like extending it to a new line segment NZ. They are both equal for a reason that you're gonna say later on. The idea here is NM equals NZ. Then NZ is the new line segment formed by extending ON by adding a new point Z. The reason is roller postulate. So that's the idea of roller postulate. We just created a new line segment NZ. Number 2, line segment NM is congruent to line segment NZ. This is the direct consequence of our first statement. In number 1, we say that they are equal, therefore they should be congruent as well. Number 2, the definition of congruent segment. This is the reason why these two statements are connected to each other. Again, NM equals NZ, therefore NM is congruent to NZ. We have here number 3, angle 1 equals angle 2. Since they are congruent, they should have the equal angles via virtue of isosceles triangle theorem. If they have the same length, two angles equal. Number 4, the measure of angle 1 is congruent to the measure of angle 2. They are actually congruent because of what we have said in number 3, that they are equal, therefore they're also congruent. Definition of congruent angles. Now number 5, measure of angle ZMO is greater than measure of angle 2 and the measure of angle 3. The reason for this is angle addition postulate. What we've done here is we just add the measure of angle 2 and the measure of angle 3. As you can see, this is within the scope of the big angle M, the ZMO. And again, in number 6, we have here the measure of angle ZMO is equal to the measure of angle 1 plus the measure of angle 3. Since in statement number 3 we conclude that they are equal, therefore by substitution we could say as well that they should be equal if we substitute this in another statement like in number 6. In number 7, we have here the measure of angle ZMO is greater than the measure of angle 1. Definition of inequality. We just get the angle 3 in the picture. That's why you could say that they are greater than, because in the first they are equal. Now here in number 8, OZ is greater than OM. This statement actually can be seen in the illustration that OZ is greater than OM. If one angle of a triangle is greater than another angle, the side opposite to the larger angle is longer than the side opposite to the shorter angle. So because of the angles and the side relationship, If longer side, bigger angle, shorter side, shorter angle, or small angle, smaller. Here number 9, OZ equals NO plus NZ. So this is just the addition of line segments. So the reason is segment addition postulate. We can add the segment and we can get the big picture. Number 10, OZ is equal to MN plus NO. Again, we add this one, but this time we use substitution for this, which just change MN to the NZ to MN because of what we said in number 8. Now 11, we conclude that MN plus NO is greater than MO because of the number 9 and number 10 via substitution. So there you have it. We conclude the given triangle MNO. We proved that already, and if you want to review, just review it and be familiar with the relationship in each statements given or provided in this video. So now we have here another question. Given 3 sides with the lengths 8, 1, and 6, show or answer the following. 1. What does it look like? So here, this is the real measurement, 1, 8, and 6. As you can see, we cannot form here a triangle, since if we extend it, we cannot really extend it. Actually, 1 and 6 cannot meet to each other. So here the order is 1, this number 2 question here, 1, 6, and 8. We just do it because we want to show A plus B is greater to C. But in number 3, we prove that this is not correct. That's why this is not a triangle. So for your practice problem, given 3 sides with lengths 12, 11, and 21, please show the following. What does it look like? Increasing order and inequality formation. This is triangle or not? Please show it.